Hello, Bacho. How are you? Today we are going to discuss most awaited part of the what Ionic Equilibrium. So today we are going to discuss Ionic Equilibrium part 3. In this session, we are going to discuss these 8 type of question that are based on these two concepts. See, first concept is salt hydrolysis. On salt hydrolysis, we are going to discuss these 4 type of question which are very important for the NEET exam. See, first type is to predict in which salt hydrolysis taking place. Now, in the question, there are 4 options are given, and these 4 options, 4 salts are given, and they ask predict in which of the following case salt hydrolysis is taking place. Now, how to solve this type of question we are going to discuss in this session, right? Now, second type of question is to predict type of salt hydrolysis. They also ask a particular salt is given, and they ask in this salt which type of hydrolysis is taking place. For example, cationic, anionic, or mixed hydrolysis like. Now, type 3 question on this concept is to predict in which salt extent of hydrolysis is maximum. So 4 options are given, and they ask in which of the following salt, tell me in which of the following salt extent of hydrolysis is maximum, right? Now, 4 type of question based on salt hydrolysis is to calculate pH and pOH of salt solution, and also in the calculation part they can ask to calculate the hydrolysis constant, to calculate the degree of hydrolysis. They can ask Ka or Kb value also. So these 4 type of question are possible in case of salt hydrolysis. So when you revise the salt hydrolysis, then go through these 4 type of question, and in this session we are going to discuss these 4 type of question, and also we are going to discuss in this session solubility and solubility product, right? So what is the basic concept of solubility, and what is the basic concept of solubility product, and how many type of question are arises or came from this concept in the NEET exam. So see, from this concept there are 4 type of question are possible in the NEET exam. First type is to calculate solubility product if solubility of salt is given. And now second type is to calculate solubility if solubility product is given, right? Now third type of question which are asked in this concept is to calculate solubility of a salt in presence of common N, right? And the fourth type of question is to predict in which case precipitation is taking place. So this session is for you if you want to make a confidence on these type of question. So now we are going to start salt hydrolysis, right? So in salt hydrolysis, beta, first type of question is to predict in which case hydrolysis taking place. Hydrolysis taking place, right beta? So how to answer this type of question, to predict in which case hydrolysis taking place? So 4 options are given to you like that. 4 options are given to you like that. Option A is NaCl. Option B is NH4Cl, and option C is CH3COONA. Now option D is in B and C, right? So for example, this type of question is given to you. These 4 options are given, and they ask in which case, in which salt hydrolysis is taking place. Then how to answer, how to approach these type of question. So see beta, to answer these type of question, you have to apply this key point. You have to apply this key approach or key point. You have to add water. You have to add water. A salt is given, and in that salt you have to add water. Then you got acid, and the second molecule is the base. right? So in salt, if you add the water, one acid molecule and one base molecule is obtained. If out of these two, out of these this acid and this base, if anyone is weak, if if out of acid or base, acid or base, if anyone is weak, any one is weak, then we can say hydrolysis is taking place. Then we can say hydrolysis is taking place. So this is a simple condition you have to apply on a particular salt. A salt is given, you have to add the water molecule and one acid, one base molecule is obtained. Then you have to see if out of these two molecules, any one molecule is weak, at least any one molecule is weak, then in that salt, hydrolysis is taking place. So see the example. In NaCl, if you add water, in it, then you obtain what? NaOH and HCl. Now see, this is a strong base, this is a strong acid, right? So no one is a weak. So in this salt, hydrolysis is not taking place. Okay. Now we have to see in NH4Cl, then you have to add water in NH4Cl. If you add water on it, then it forms what? NH4OH, right? And HCl. And how to write this base and acid? Simply you have to divide into two parts, cationic and anionic part in this way, and you also break the water molecule in this way and add the opposite ions, and then in this way ammonium hydroxide and HCl molecule is formed, right? So out of these two, this is weak base, this come in the category of weak base, and this come in the category of strong acid. So out of these two, one is weak because this base is weak. So this salt undergo hydrolysis. So in NH4Cl, hydrolysis taking place. Now we have to check in case of sodium salt of acetic acid. If you add water on it, then you got acetic acid plus sodium hydroxide. Now you have to check these two, out of these two, anyone is weak or not. So this acetic acid is come in the category of weak acid, and this is a strong base. So this acetic acid is a weak, so this salt also undergo hydrolysis. So the correct option is what? In B and C, in both B and C, hydrolysis is taking place, right? So this type of question are solved with the help of simple condition, with simple this key point, right? So now type 1 is clear to all. Now we have to move in type 2, right? Okay. Now we have to see type 2 beta. We have to see type 2 question. In type 2 question, they ask to predict in a given salt, which type of hydrolysis taking place. So how to answer this type of question? A salt is given and they ask in the given salt which type of hydrolysis is taking place. So see beta, how to answer these type of question. To answer these type of question, first you have to see types of hydrolysis, right? We have to see type of hydrolysis. So basically 3 type of hydrolysis are present in salt. First one is cationic hydrolysis. Cationic hydrolysis. Second one is anionic hydrolysis. Right? And third one is mixed hydrolysis. Mixed hydrolysis. Right? So see how to check in a particular salt which type of hydrolysis is present. Now I am giving you the approach, how to approach. See, for example, CS3COO Na, this molecule is given. Then to check which type of hydrolysis is present in a particular salt, first you have to add water on that. Then you have to add water on that. Then one acid molecule and one base molecule is formed. So here CS3COOH plus NaOH is formed. And now you have to see out of these two molecule, acid and base, which one is weak. So we have to see this is a weak acid, right? And this is a strong base. Now you have to see this weak acid came from which part? This weak acid came from which part of the salt? Now you have to divide this salt into two parts, cationic and anionic. So these two parts are CS3COO1 minus and Na1 plus, right? So this weak acid came from this part, right? Came from this part. So this has what? Negative charge. So in this molecule, we can say anionic hydrolysis is taking place because this weaker part came from this anionic part. So in this salt, anionic hydrolysis taking place, right? So this is the way to predict anionic hydrolysis. Okay, now how to check cationic hydrolysis and how to check mixed hydrolysis. So let us take one more example. For example, if I am taking NH4Cl salt, NH4Cl, and now we want to check which type of hydrolysis is present in this salt. Then we have to, first we have to add the water in this salt. Then one acid and one base molecule is formed, NH4OH and HCl is formed here. Now we have to see out of these two, which one is a weak. This is a weak base and this is a strong acid, right? So now we have to see this weak base came from which part of the salt, cationic or anionic. Now we have to break this given salt in cationic and anionic part in this way. Now this weak base part came from cationic part. So in this salt, which type of hydrolysis is taking place? That is called cationic hydrolysis is taking place, right? So in this salt, cationic hydrolysis is taking place. So in this salt, cationic hydrolysis is taking place. Now we have to take one more example to understand mixed hydrolysis. Now example number 3. For example, NH4Cl. This salt is given. Now you have to check in this salt which type of hydrolysis is taking place. Then first you have to add the water in this salt. If you add water in this, then one molecule of ammonium hydroxide and one molecule of HCN is formed. So now see, this is weak base and this is weak acid. So in this salt, both part, basically acid and base, both are weak. So we can say in this situation, mixed hydrolysis is taking place. Mixed hydrolysis is taking place. So what is the concept of mixed hydrolysis? If acid and base both are weak, in that case mixed hydrolysis is taking place in that given salt. So this is a simple concept. Just a quick revise. See, there are three type of hydrolysis: cationic hydrolysis, anionic hydrolysis, and mixed hydrolysis. So when there is a cationic hydrolysis, when that weaker part came from the cationic part, then this is cationic hydrolysis. If weaker part came from the anionic portion, then it is called the anionic hydrolysis. If both are weaker, then there's a mixed hydrolysis. So type 1 question is clear to all. Now we have to see type 2 question. Now see what is type 2 question. This is basically type 3, not type 2. Type 2 is already covered. In type 1, we have to predict in which salt hydrolysis is taking place. Type 2, which type of hydrolysis is taking place. And type 3 is in which salt extent of hydrolysis is maximum, right? So to predict in which salt extent of hydrolysis is maximum. Extent of hydrolysis is maximum. Then how to answer this type of question? So to answer this type of question, you simply apply one condition. In given salt, you have to check in which salt both part undergo the hydrolysis, cationic as well as anionic. The salt in which both part undergo hydrolysis, in that salt we can say extent of hydrolysis is maximum. So what is the basic approach? What is the key point? Key point is the salt in which both means what? Cationic and anionic part undergo hydrolysis, in that case we can say extent of hydrolysis is maximum. Now let us see one example. For example, they ask in which salt extent of hydrolysis is maximum. Extent of hydrolysis is maximum. Option A is NaCl. Option B is CH3 COONA, sodium salt of acetic acid. Option C is ammonium chloride. Option D is ammonium cyanide, NH4Cl. Now you have to check in which case extent of hydrolysis is maximum. So it is very easy. It is very easy to answer this type of question. So how to check? You have to add the water in each salt and you have to just check in which case both parts are weak, acid as well as base. In that salt, the extent of hydrolysis is maximum. Now we have to see. First, we have to add water in this, right? Then you got sodium hydroxide plus hydrochloric acid. So both part are what? Strong. This is a strong base. This is a strong base. This is a strong acid. So in this case, hydrolysis does not take place, right? Now you have to check in this case. So here you got acetic acid and sodium hydroxide. So this is weak acid and this is a strong base. So one part is weak. Now we have to check in C part. If you add water, then you got ammonium hydroxide plus HCl. So in this C part also, one part is only weak. So this is weak base. This is a strong acid. Now we have to check for the D part. If you add water in D part, then you got NH4OH plus HCl. Now see, this is weak base and this is weak acid beta. So in this part, in option D, both acid and base are weak. So in this salt, the extent of hydrolysis is maximum. So we can say in D option, extent of hydrolysis is maximum, because in this salt, both acid and base part are weak, right? So this is the way to answer these type of question. Now we have to see type 4 question. That is a more very interesting, right? And this is based on calculation, right? Now we have to see type 4 question, beta. Now type 4 question, right? Type 4 question is to predict pH and POH, or sometimes they call H, sometimes they can also ask KH, and sometimes they also ask Ka and Kb. Right? So to predict the value of pH, POH, or H, where H is what? H is a degree of hydrolysis. Now we have to tell you this H is a degree of hydrolysis. Degree of here Kh is the hydrolysis constant. Hydrolysis constant. And Ka is what? Ka is a dissociation constant of weak acid. Dissociation constant of weak acid, and Kb is dissociation constant of weak base. Dissociation constant of weak base, right beta? So in type 4, which are based on what concept of hydrolysis, they can ask to calculate pH and pOH. Sometimes they can ask what is the degree of hydrolysis of the given salt. Sometimes they ask what is the hydrolysis constant of the given salt. Sometimes they ask what is the K and the Kb value of that weak acid and the weak base, right? Then how to calculate these values? So now I am going to give a particular approach with proper explanation how to solve these values, right? Let us see. For example, I'm assuming here for anionic hydrolysis. For anionic hydrolysis, how to calculate pH value, pOH value, and Ka or Kb or H and KH. So how to proceed anionic hydrolysis, right? Let's see. For example, this salt is given to you. For example, this salt is given to you. I am taking that salt in which anionic hydrolysis is taking place. So in this salt, sodium salt of acetic acid, anionic hydrolysis is taking place. Now, in the question it is given to you, the concentration of salt is given in the question. For example, this is C, right? And this is a mole per liter. And in the question, Ka value is also given, right? And already you know the Kw value for the water, right? For water at 25 degrees Celsius. So these three things are given to you in the question. These three things already given in the question. Now you have to solve, you have to calculate these parameters. You have to calculate these parameters. What are these parameters? First, you have to calculate what is the concentration of H positive ion, or what is the concentration of OH minus ion, right? Basically, you want to calculate what is the pH value, what is the pOH value of the given salt solution, and then you have to calculate what is the degree of hydrolysis. Then you have to calculate what is the hydrolysis constant, KH value, right? So these things we want to calculate in the particular question, right? Now, how to proceed? Here we are taking CH3COO minus and Na plus, and we know in this anionic part hydrolysis is taking place. This anionic part hydrolysis is taking place. So we take out only this anionic part, right? And we have to react this anionic part with water because we want to do the hydrolysis. So if you react it in water, then the hydrolysis process is taking place, and here acetic acid is formed and OH1 minus ion is released, and here equilibrium constant is defined as KH, because in this process hydrolysis is taking place. So in place of equilibrium constant you can write KH, where KH is a hydrolysis constant, right? And in the question it is already given to you at T is equal to 0 time the concentration of this acetate ion is C, right? And initially these things are not present, and it is already taken in excess, so there's no need to take this concentration here. Now you have to see at t is equal to t time, when equilibrium is taking place, at that time what is the concentration of this acetic acid? The concentration of this acetic acid is CH, and this is also CH. Here H is a hydrolysis, degree of hydrolysis it is just as degree of dissociation alpha. Here hydrolysis is taking place, so in place alpha we have to take H, right? So H is here degree of hydrolysis. So the concentration of this acetic acid in term of degree of hydrolysis, and C is CH, and the concentration of OH minus ion is equal to CH here. Now basically we want to calculate this concentration to calculate the pH value. To calculate the pH value, we want to calculate the concentration of OH minus ion, and that is equal to CH, and C is already given in the question. Basically we want to calculate the value of H, degree of hydrolysis, right? If we are able to calculate this H, that is called degree of hydrolysis, then we are able to calculate POH value. If we are able to calculate POH value, then we are able to calculate pH value using the formula pH plus POH gives out 14, right? Now let us see how to calculate this H value. Okay, so see, the concentration of this acetate ion at T is equal to T is equal to C1 minus H is there. Okay, so we can write KH is equal to concentration of acetic acid using the above equation into concentration of OH minus divided by concentration of acetate ion, right beta, and concentration of water, this is taken as 1, right? So this is equation number 1. Okay, this is equation number 1. Now we have to put the values of concentration of acetic acid, concentration of OH minus ion, and the concentration of acetate ion in term of CH. Now if we put these values, then we got KH is equal to CH into CH divided by C1 minus H. Now C and C is cancel out, then you got KH is equal to CH square divided by 1 minus H. So you got the value of KH is CH square divided by 1 minus H, right? So we have to use the approximation, because in general, in all the questions which are asked in the NEET exam, this approximation is applicable. So what is the approximation? Let us see. If the value of H is less than or equal to 0.1, then we can take 1 minus H is approximately equal to 1.0. Now we have to put this approximation in the question number 2. Then we got KH is equal to CH square divided by 1, right? So we got KH is equal to CH square. So we can also write in this way, H is equal to under root KH by C. So in this way, you are able to calculate the value of degree of hydrolysis. So degree of hydrolysis of this anionic salt is equal to under root KH by C, where KH is a what? Hydrolysis constant. Now we have to see how to calculate KH, because in the question the KH value is not given, this C value is given and KH value is not given. If we are able to calculate the KH value, then we are able to calculate H value, and if we are able to calculate H value, then we are able to calculate concentration of OH minus ion, because all of we know that concentration of OH minus ion, this is equal to what? CH. So if you are able to calculate this H value, then you are able to calculate the concentration of OH1 minus ion. Now we have to see how to calculate this KH value, right? So see, let us see. From equation number 1, we have KH is equal to this is a concentration of acetic acid into concentration of OH minus ion divided by concentration of acetate ion, right? Okay, this is okay. Now in this equation, if we multiply concentration of H positive ion, and we have also divide concentration of H positive ion, right? So there is no effect in this equation because we have just multiplied by the same entity and also divide by the same entity. So there is no effect, right? But we make a particular relation right here. See how? So this value you have to see is equal to what? Kw, right? And now see, if we take this concentration of acetic acid on the denominator, then can I move in this way? See, can I take in this way? If we rearrange it, this one, CS3COOH. Now you have to see this value is what? This value is Ka for the acetic acid. This is for Ka for acetic acid. Do you know? Acetic acid dissociate in this way. CS3 COO1 minus and H1 positive. So here Ka is defined. So in this way, this Ka is what? The concentration of acetate ion into concentration of H positive divided by concentration of acetic acid, right? So ultimately we can write this KH is equal to Kw by K, right? So now we got the relation between KH, Kw and K, and already in the question it is given Kw value and K value is already given. So using these value, you are able to calculate KH value. Now if you are able to calculate the KH value, then you just put this KH value, which is Kw by Ka, in this equation. H is equal to under root KH by C, right? If you put this KH value here, then you got Kw by Ka into C. So you got what? Formula to calculate degree of hydrolysis. So degree of hydrolysis is equal to under root of Kw divided by Ka into C. And these value already given in the question. These value already given. This is also given. And this is also known. And this is equal to what? 10 to the power minus 14 at what? 25 degrees Celsius. So already known value. So now you have put the value of Ka and C and the Kw, then you are able to calculate this degree of hydrolysis. If you are able to calculate degree of hydrolysis, then you are able to calculate the concentration of OH minus ion. See, so concentration of OH minus ion is equal to CH. Now you have put the value of H from here to here, right? So if you put this value from here to here, then you got C into under root of Kw by Ka into C, right? So if you take this C inside, then you got Kw into C by K. So this is what? This is the concentration of OH minus ion. So ultimately we conclude here, ultimately we conclude here OH minus ion is equal to under root Kw into C by K, right? So the concentration of OH minus ion is this. So using the concentration of OH ion, you are able to calculate POH value. So POH is equal to minus log of concentration of OH minus ion. Now you have put this value from here to here, then you got minus log of Kw into C divided by Ka की power 1 by 2. Now you have to use the property of log. If you are using the property of log, then you got 1 by 2 and in bracket log Kw plus log C, right? And this is minus log K. Then you obtain this expression. Basically, I want to derive the relation which you have to learn, right? So here POH is equal to 1 by 2 log Kw plus log C minus log Ka, right? Now we have to put the value of Kw. The value of Kw is 10 की power minus 14 beta, right? So if you put this value here, then you got minus 1 by 2, right? And in bracket, this is minus 14 because log 10 is 1 and plus log C, and this minus log Ka is equal to what? pKa, right? Minus log Ka is equal to pKa because pK is equal to minus log Ka. So you put this value pKa, right? Now if you take minus 1 by 2 inside, then you got from here, we have to write the relation here. So POH is equal to 7 minus 1 by 2 log C and minus 1 by 2 pKa. So ultimately you got the relation POH is equal to minus 7, not minus 7, this is plus 7, plus 7 minus 1 by 2 log C plus minus 1 by 2 log 1 by 2 pK. Now if POH is known, then how to write the formula to calculate pH? So just simply use pH plus POH gives out 14. So pH is equal to 14 minus POH, right? If you are using this formula, then you got pH is equal to 14 minus, so you got 7 and then plus 1 by 2 log C plus 1 by 2 pKa. So in this way you got the relation to calculate pH and POH of given salt solution, basically the salt in which anionic hydrolysis is taking place. In that case, you are able to calculate pH and POH of the solution using this way, and you are also able to calculate degree of hydrolysis and hydrolysis constant. So I have given the complete explained way to calculate how to calculate basically H value, KH value, pH value, POS value, Ka value, and Kb value, right? So see, so now see how to proceed for a particular question. Now we are going to conclude this concept, right? So see, if any salt is given, in that salt, if anionic hydrolysis is taking place, anionic hydrolysis is taking place, in that salt, you are able to calculate, first you are able to calculate concentration of OH minus ion, and this is equal to CH. So first you have to use this formula. Now you have to calculate H value. This H value is what? KH by C here, right? And now you have to calculate this KH value, and this KH value is equal to KW by Ka, right? Now you have to use these three formula, then you are able to calculate the concentration of OH. If you are able to calculate the concentration of OH, then you are able to calculate POS value. If you are able to calculate PS value, then you are able to calculate PS value using this 14 minus POS. So better don't remember the basically explained formula, standard formula. Just go like this, right, for the particular question, right? So this is the very easy approach to solve the question. So just using these three formula, you are able to calculate H value, KH value, pH value, POS value in case of anionic hydrolysis. And in the similar way, you are able to calculate pH, POH, H and KH value for the cationic hydrolysis. So let us see using the analogy, right? Now, for cationic hydrolysis, So for cationic hydrolysis, we are not going to do all the explanation, all the derivation. We are just go through analogy, just like what? Anionic hydrolysis. So we have to see how to proceed cationic hydrolysis. See, this is the example. NH4 Cl. In this, cationic hydrolysis is taking place. So we have to just remove this cationic part from NH4Cl, and we have to react this cationic part with water, and then you have to see NH4OH plus H positive ion you obtain. So if the concentration at T is equal to 0 time is C for NH4 1 positive ion. So at T is equal to T time, the concentration of this is CH, and this is also CH, right? And this value is C1 minus S. So proceed this question in the same manner, right? So here basically we want to calculate the concentration of H positive ion. In case of cationic hydrolysis, if you do the hydrolysis, then first you got the concentration of H positive ion. Here the concentration of H positive ion you got, that is equal to CH, right? Here you got the concentration of H positive ion is equal to what? CS. So now just proceed in the same way as you have the proper funda for the what? Anionic hydrolysis. So in the side I am going to write for anionic hydrolysis, anionic hydrolysis, just for reference, right? So in anionic hydrolysis, you first calculate concentration of OH, that is equal to CH, and then you have to calculate the value of H, this is equal to under root KH by C, and then you have to calculate KH value, and KH value is what? KW by Ka. So in the same way, you are able to calculate the value of H positive ion, the concentration of H positive ion in case of cationic hydrolysis is equal to CS. Then you have to calculate the value of H in case of cationic hydrolysis. So this is equal to KH by C, same formula, right? And in the third, the KH value here is equal to what? KW by KB, not Ka. Here, in case of anionic hydrolysis, this is Ka. In case of cationic hydrolysis, this is Kb. The only difference is that, right? And if you are able to calculate the value of H positive ion, then you are able to calculate the value of pH, because pH is equal to minus log concentration of H positive ion. Now you have to put this H positive ion concentration from here to here, and then you have to calculate POH value, and POH value is equal to 14 minus PS. So using this simple formula, you are able to calculate pH and POH of any salt which contain cationic hydrolysis. So now you are able to solve the question based on cationic hydrolysis, anionic hydrolysis, right? In these cases, you are able to calculate the concentration of H positive ion, concentration of OH minus ion, and the value of degree of hydrolysis H, and the value of hydrolysis constant. And also you are able to calculate the Ka value or Kb value of the given what weak acid and a weak base, which involve in salt hydrolysis, right? So let's see. Now we have to take the question, right? See. HX is a weak acid, that is a Ka. K is a given. It forms a salt, NaX, right? On reacting with caustic soda, the degree of hydrolysis of NaX. So here the given salt is NaX. So now first we have to identify which type of hydrolysis is taking place in this case. Now see here, if you put water in it, then you got NaOH plus HX. So here this is a strong base, this is a weak acid. So hydrolysis is only due to this weaker part, and this weaker part came from this negatively charged species. So in this case, anionic hydrolysis is taking place. Anionic hydrolysis is taking place. Now we are able to understand which type of hydrolysis is taking place in this question. Now we have to solve for the anionic hydrolysis. For anionic hydrolysis, we already know the concentration of OH minus ion is equal to what? CH here, and H is equal to what? Under root KH by C, and we also know KH is equal to KW by Ka, right? So using this formula, you are able to calculate degree of hydrolysis, because in this question they ask degree of hydrolysis. They ask what is the H value, right? So what is the H value? So H is what? From here, H is equal to under root kh by c. Now you have to put the value of kh. Kh is equal to kw by k. So you can write kw by Ka into C. Now we have to put these value from the question. Ke is given in the question. K is 10 to the power minus 5 and the concentration is also 0.1. Now you have to put, and Kw is already known. That is 10 to the power minus 14. So 10 to the power minus 14 divided by Ka is 10 to the power minus 5 and this C is 0.1. So we can write 0.1 as 10 to the power minus 1. So if you solve this, you got 10 to the power minus 14 beta and divide by 10 to the power minus 6. Then you got 10 to the power 14 minus 14 plus 6. Then you got 10 to the power minus 8. And if you remove this value and you solve, then you got 10 to the power minus 4. So is there any answer 10 to the power minus 4? So 10 to the power minus 4 is also equal to 0.0001, right? So B answer is right. See, this is the way to solve the question. Now let us take one more example, right? So see the question. The degree of hydrolysis in hydrolytic equilibrium, that is A minus plus H2O, gives out HA plus OH1 minus at salt concentration of 0.001 molar is, and K is given in the question. Basically they ask in the question degree of hydrolysis. Now first we have to see what parameter are given in the question. So see, in the question they give the concentration of salt is 0.0001 molar. You can also write in this way 10 to the power minus 3 molar. And the Ka value is also given in the question. Ka is what? 1 into 10 to the power minus 5 beta. Right? Now you have to solve hydrolysis, degree of hydrolysis. You have to solve what is the value of H here, right? You have to solve what is the value of H here. Now we have to know which type of hydrolysis is taking place. So see here, A minus is there. So using this basically given information, we are able to identify anionic hydrolysis is taking place. Anionic hydrolysis is taking place here, right? Because anionic hydrolysis is taking place, then we are able to calculate the value of H using this formula. H is equal to under root Kw Ka into C, right? So using this formula, you are able to calculate the value of degree of hydrolysis. Now you have put the value of Kw, Ka and C here. If you put the values in this expression, then you got 10 to the power minus 14 divided by Ka is 10 to the power minus 5, 10 to the power minus 5, and the value of concentration is 10 to the power minus 3. This is 10 to the power minus 3. Then you got under root 10 to the power minus 14 divided by, this is 10 to the power minus 538. Then you got under root of 10 to the power minus 6, right? If you solve this value, then you got 10 to the power minus 3, right? So the value of H is 10 to the power minus 3. So answer A is right. So using this approach, you are able to calculate the value of H, or you are also able to calculate the value of pH, pOH of the given salt solution. Now see, okay, so this concept is over. Now the concept of salt hydrolysis is over. Now we have to see concept of solubility and solubility product. Which type of question are asked from solubility and solubility product? Let us see. Type 1 question based on solubility and solubility product. So type 1 question is that to predict or to calculate, to predict the solubility it is represented by small s if solubility product is given. If solubility product of salt is given, if solubility product of salt is given, right? So how to solve this type of question? No, what is the approach for this type of question? So I am taking a general example of a salt. For example, AX by, this type of salt is given to you. Here x and small y are variable, but for a particular salt these are the numeral value, right? So if this salt put into water, then it gives these ion Xa y positive and Yb x minus. Now we have to write in term of solubility. So in term of solubility, the concentration of this ion is equal to what? X into S, and the concentration of this ion is equal to Y into S, where S is the solubility. S is the solubility, right? And here KSP is defined. Here the equilibrium constant defined is KSP, right? So here the KSP, and KSP is a what? Solubility product, right? So KSP is equal to concentration of A y positive की power x and B x minus की power y. Now you have put the values in term of solubility here. So in term of solubility, this is xs की power x and this is ys की power y. Now if you solve these values, then you got x की power x and y की power y and s की power x plus y. So you got the expression for KSP is x की power x, y की power y and s की power x plus y. So using this expression, you are able to calculate solubility product, right? If solubility is given. Now if solubility product is given, then how to calculate the solubility? So see, using the same expression, we are able to calculate, right? So because you know KSP of that salt is x की power x and y की power y, y की power y and s की power x plus y, right? So solubility S is equal to KSP divided by x की power x and y की power y, right? And to the power 1 by x plus y. So in this way you are able to calculate what? You are able to calculate solubility if solubility product of a particular salt is given. So now we are able to do these basically two type of question. If solubility of a particular salt is given, then how to calculate solubility product. If solubility product is given, then how to calculate solubility of particular salt. So in this way you are able to calculate these type of question. Now let us take some example. Are you able to write the expression for solubility product? Are you able to write the expression for solubility in term of solubility product. Now let us take some example. For example, example number 1, write solubility product of given salt in terms of solubility. Literally, if solubility is given as S, right? For example, given salt are, first salt is A to B. This is salt is given, and the solubility of this salt is given to you S. Now you have to calculate the solubility product for this salt. Then how to calculate? C. You have to do in this way, 2A 1 positive plus B2 negative. First you have to ionize the given salt, and then you have to put the concentration of salt in term of its solubility. So this is 2S here, beta, because 2 is there. So and solubility of salt is S. So 2, just multiply 2 into S. So this is 2S, and this is what? S. So what is the solubility product expression for this? Solubility product of A to B is equal to concentration of A positive की power 2 into concentration of B2 minus, right? Now you have put the values here. So the value of A, concentration of A positive ion is, this is 2S की power 2, and here this is S, then you got 4S cube. So using this expression, you are able to calculate the value of solubility product. The value of solubility product is 4S cube. Now if solubility is given, then you just put the value of solubility here and calculate the value of KSP. Sometime in the question, solubility is not given. They give the concentration of a saturated solution. They give the concentration. For example, they give the concentration of what? A positive. They give the concentration of A positive in the saturated solution. So if they the concentration of A positive ion in the solution, basically for saturated solution, then first you have to equate this concentration of A positive ion is equal to 2S, and now you have to calculate the value of S from here. This is equal to concentration of A positive ion divided by 2. So using this, first you have to calculate the value of solubility. Now if you are able to calculate the value of solubility, then you just put this S value from here to this expression, and you got the value of solubility product of a particular salt, right? So this is a very simple way, beta, to solve. So thank you so much. So, Bacho, in the next session, we are going to discuss thermodynamics. This is a very, very important chapter and a very crucial chapter for the NEET exam. So, in the next session, we are going to discuss question based on thermodynamics. And basically, we have also divided the question of thermodynamics into different type 1 question, type 2 question, and type 3, and we are going to take how to calculate work done in case of isothermal reversible process, in case of adiabatic reversible process, and irreversible process. So let's see